Okay, here's your Chapter 7 test. On the first 3 questions, we're going to use the Pythagorean theorem. You can see it's listed right here. The most important thing you need to make sure you do on every one of these is to label your sides. Always label your sides first. So again, when you look at that right angle, he kind of makes a point because he's pointing at the hypotenuse, which is C. Make us A, make us B, it doesn't matter which one. Okay? So on these other ones as well, look and find where's your C. He's here. The C. He's here. A and B don't matter what order you put those in, okay? So that's for 1, 2, and 3. For 4 and 5, all you got to do is plug these sides into the Pythagorean theorem. And remember that the longest side is always going to be C. And when you work it out, if they're equal on both sides, then it's a right. Okay, so I'm going to write that in blue up above here. If it's equal, it's a right. If the left side is bigger, the AB part is bigger, then it's acute. And if the right side is bigger, it's obtuse. You're doing the same thing on number 6. But the one thing you want to check out first is plug this into the calculator, 3 radical 34, and see what decimal number it is. Make sure of who is the actual longest side here. Is it 15 or is it this guy? And then do what we did on the last page. We need to remember our rules of 45, 45, 90 triangles. Okay, so I'm going to write that right here. If I have radical, and if this is 45, this one's 45, then my sides are the same, if the angle is the same. And then the hypotenuse is, all you got to do is take the side and multiply it by radical 2. Okay, so that's all you got to do in 7. Now in 8, I'm going to zoom in here and point out that they give you the hypotenuse, not the side. So again, according to our rule, okay, they give us this part in that next one. They give us, I think it was 12 or whatever it is. But so you had to take x and multiply it by radical 2. So to get the side, you got to do the opposite, which would be to divide by radical 2. So you're going to take this and divide by radical 2. For 9 and 10, they're talking about 30, 60, 90 triangles. So here's your rules again with those. There's my right angle. 30 is my side, or my smallest angle. 60. Now, opposite the smallest angle is the smallest side. Okay, and then to get the side across from 60, you take the smallest side and multiply him by radical 3. And to get the hypotenuse, you take the smallest side and double it, multiply it by 2. Okay? So to figure out your x, okay, this is going to be your long side because this is the 60 degree right here. This is the 30, so that's a short side. So just like here, what do you do with the short side to get the long side? Do that here. And then for y, what do you do with the short side? We doubled it here, so double it there. Okay, in question 10, the next page here, yeah, kind of rolls over. Okay, they give you the long leg in question 10. So to go from long leg to short leg, if we went from short to long, we took this times radical 3. So you do the opposite. And once you figure the x out, to get y, we're just going to double it. In question number 11, they give you the hypotenuse. So again, find the short leg. It's going to be this guy here. Y is going to be the shorty. You take the shorty times 2 to get the hypotenuse. So you got to do the opposite to get your y. And then take that times radical 3 to get your x. In question 12, this is a 45, 45, 90 because these angles are the same. So these are both 45. Okay? So it means if the angles are the same, that means the sides are going to be the same. So again, to get the hypotenuse, you take the side times radical 2. So we need to do the opposite of times radical 2, which is divide by radical 2. Okay? And remember, you cannot have a radical in the denominator, so you got to multiply by himself. And I'll let you solve it from there. Make sure you simplify. But you should have the same answer for x and y. 13, we got to use our trig function here. Make sure we always label our sides first. So here's your 90-degree angle. It's pointing to the hypotenuse. We're going to use angle 38. That's our reference. So as you look across, this would be your opposite. This would be your adjacent. So which of these trig functions do you use? On this one, I'll help you get started. And that you should use tangent because you don't know anything about hypotenuse. So it leaves sine out and cosine out. We got to use tangent. So you're going to say tangent of 38 equals 4 over x. And you solve from there. Same thing in number 14. But label your sides first. Again, here's the 90-degree angle. He's pointing at the hypotenuse. Now we're using 53 as our reference. You look over, there's your opposite. There's your adjacent. You choose the trig function you need to use and solve to find x. Find this side. You need to find the opposite side. Just giving you kind of a larger view here. 15 through 18 are all the same as what we've been doing. Okay? You got to choose the trig function. Now I labeled the triangles for you on the first couple. You should label the rest, but make sure you label the hypotenuse first and then look at your reference angle to label the opposite and the adjacent. Okay? And you're just solving to figure out the side. Now, moving on to 19, they want us to figure out how many degrees angle P is, how many degrees this is. So this is my angle of reference, which means I label this would be the hypotenuse, of course, this would be the opposite side, this would be the adjacent. So now you want to use the inverse of tangent times opposite over adjacent, which is 20 over 14. Round it to the nearest tenth. That's 1 decimal place. Okay? Now I'll tell you how many degrees angle P is. Number 20 and 21 are the exact same as 19. Okay? Again, label your parts first. Here's my hypotenuse. And they want to know angle P. Okay? So I would make this the opposite. 17 is the adjacent. We also want to know angle P in 21. Again, label your points. There's my hypotenuse. This would be my opposite, and this would be my adjacent. Okay, 22 and 23, we want you to first solve for the missing side, which is AB. Okay, use Pythagorean theorem on number 23. Now, number 22, you can't do that. So we're going to call this side X. Okay, and this would be my opposite side. There's my hypotenuse. This would be the adjacent. Okay, so since we have something with hypotenuse and we're dealing with adjacent, that means you're going to want to use cosine because it's adjacent over hypotenuse. So set that up. That's how you're going to figure out how long AB is. Okay? And then do the same thing for BC, other than you're going to want to use sine for B. So that's for that part. You're going to use sine of 50 equals the opposite over the hypotenuse. Okay? In number 23, again, like I just told you, to figure out AB, go a squared, b squared, c squared. So this would be my c, this would be my a, that would be my b. So use the Pythagorean theorem. I'm writing that down here for you. To figure out this. Now, to figure out angle C, okay, in both of these, actually, you got to use an inverse like we just did up above. Okay, so angle C is your reference angle, which would make this the opposite side, this the adjacent side. Makes this the opposite side, and this the adjacent side. So to figure out C in 22, you're going to want to use probably, I would use sine again, the inverse of sine. And that's going to be whatever you got for this value here for AB over 9. Okay? And then for down here, we're going to want to use, again, whatever you got for AB over the hypotenuse. We're going to use cosine now. The inverse of cosine is whatever you got for AB divided by 12. And that'll give you how many degrees angle C is. And that's the end of your Chapter 7 test. So if you need help or you have a question, ask Mr. Houston or myself. Have a great rest of the day. God bless.